Hello students, today we are trying to study the exercise problem of chemical kinetics students. Okay, so we are going to be the live on the YouTube and as well as the class plus student. So let's try to have a look over it, the problem, exercise problem we are seeing student. So what are the exercise problem? First of all, let us try to understand question number 1 we are starting student. Okay. So when you talk about the question number 1, let me check whether we are being live or not student on the YouTube, but we need to check also. Yeah, it's being okay. We are going to be live on its YouTube students also, so that's all correct. So here is students. Yeah, so question number 1 you see student, what are the question number 1 here they have given. So they are saying from the expression here student, rate expression for the following reaction, determine their order of the reaction and dimension of the rate constant student. So if you see, the dimension means the unit they are asking student, this is they are asking unit. So here they have given the first one, let us have a look over the first one. It is the going to be 3NO, gas is there, it is going to give N2O, right? And here rate is depending on what student, rate is depending on NO only, so it is KNO, and here is power 2. Student, you see the in the reaction, if you see the in the reaction it is given what 3, here coefficient is going to be 3, but here what is the power is what is there 2 only, so it is the experimental student. Okay, order is experimental. So you got to know student, if you write order is what student, that is sum of power of concentration. What is order student? Sum of power of what student? Concentration. So in the concentration term, what is the power here you see student, the power is 2. So if you see, that is what is the order, if someone is asking that is order, exactly you can say that is it is the second order reaction. And now the what the most important thing is, that is they are talking about the what is the dimension. Okay, dimension. So student, dimension we can derive from this expression only. Okay, from there. So rate we write student, what we can write, that is dNO, simple terms, that is we write dNO by dt. This is what the rate, here negative sign will be there, and here is what is the K is there student, and what is the NO, and power going to be 2 student. So this is what the expression we are writing. Negative sign is only, it is telling that is the concentration of reactant decreasing. It is nothing related to the how speed cannot be negative. So that is, it is the symbol represent for the only that is concentration decreasing, that much only. Now student, here you come out to be the this case, here you see the concentration, what is what we can write here is mole per liter. So mole liter inverse, time is there second. Okay, here is K is there, and here mole per liter it is going to be square student. So I am writing mole per liter. One more time we have to write, because it is the square, mole per liter, right? This mole per liter and this mole per liter is cancel out student. Now send all the things on the left side. So what is here is already, if mole it will go this side student, so it will be in the divide. So numerator you are sending student, let me write here 1 by second already there, it will mole will go student, and liter inverse will go, liter inverse. Now you rearrange student, if you are rearranging, so it will give one that is in the numerator, if you are placing this all the value student. So how can you place the numerator? So mole, it will be the mole inverse. If you are going in the numerator student, it will be the mole inverse, right? So let us see the, it is little bit hanging out the tab problem. So whatever the numerator denominator things go on the numerator, it takes the power of the negative student. Let me see student, why it is the, yeah, it's came now. So here is the mole inverse. Okay, liter will go numerator, so already negative is there, it will become positive, mole liter, and it is second inverse. So this is what the unit of the second order reaction is, student, right? So now we are going for the next one, student. What can be the answer number, next question number second one? So let me firstly erase this one. So what is there? H2O2 reacting with the 3I minus, right, student? And in the acidic medium, that is 2H plus, what it is going to give, student? It is going to give 2H2O plus I3 minus. Okay, so rate, if you see, rate is depending on the H2O2, along with it is depending on the I minus also. Okay, and then they are asking the what is the order of reaction. Our question is they are asking the order. Here you see, that is from the expression following, determine their order. First thing's order, and second thing dimension. So second one I am writing here, student. You see that is second problem. So H2O2 is there, student. H2O2 plus 3I minus plus 2H plus. Here what it is going to give, student? 2H2O plus I, and here is 3 minus, I3 minus. So rate they have mentioned, student, rate. So rate we are writing the at the place of in spite of writing RAT, just you mention R. So rate is equal to what is there, student? This is the K. Here is H2O2, right, student? This is H2O2. This will be in the square bracket, and here is I minus. These things are there. Power is nothing. It means the power, both are power are the 1. Order, how we write, student? Order is, so order we write that is sum of power of concentration in the rate law. So sum of power of concentration 1 plus 1. So it is also going to be what? Second order, student. So order is second. Now the next point is what? Dimension. Dimension, that is for the just now I told you, student, what will be the dimension of second order. But again, if you derive, student, so R is equal to what? K, and concentration it will be the square, right? So rate is what, student? Mole liter inverse and second inverse. This is what rate. Here is K as it is. This is what is the mole is concentration square. Concentration with what is done? Mole per liter, square is there, so you can write again mole per liter. Now this mole per liter and mole per liter will be cancelled out. So K is equal to, here is second inverse is there, remaining you are sending the left side, student. So it will go in the denominator, mole per liter. Now you rearrange this one. So mole will go in the numerator. What will numerator? So mole inverse. Liter will go in the numerator. So here negative sign. So liter will become positive. Liter, and second inverse is already there. So mole inverse, liter, second inverse. This is what is the answer, student. Okay. Now let's go with the second one, student. If we talk about how can we pin hydol annotation, I'm just thinking that if I can erase all, but here no option I am able to find out. So let us go, what can we do? So third one, you see, student, third one, acetaldehyde, it is going to give the CH4 and CO, and rate is depending on the K power, K CH3 CHO power 3 by 2. So this reaction is what the reaction is what, student? Fractional order. Order is will be 3 by 2. Okay. So what we can do, the order, the simple I am writing, I am not writing the question again. So rate they have given, how much rate they have given, student? It is K, in the square bracket what is there, student? CH3 CHO, it is 3 by 2. This is there. So order is simply sum of power of concentration, so it is already given 3 by 2. Dimension they are asking, student, unit, that is the important things. So how can you write the unit? So R is equal to, we can write that is K, and concentration power what is 3 by 2, right? Let it be like that. So rate is equal to what, student? Mole per liter per second equal to K. Here is what, student? Mole per liter multiply by what, student? Mole per liter. So let us write the K. So what is there? mole per liter per second divided by what, student? Here is mole per liter multiply by again mole per liter. So this mole per liter and this okay, wait, sorry, not here, the power is not the same, student. Power is not the same. So power is not the same, so it is going to be what, the different case. What is the mole per liter, and it will be, the power will be 3 by 2. So what will be there, student? So you cannot cut out this one also, this will be also same. So say, so mole power 3 by 2, and liter is there, liter inverse. So if you multiply minus 3 by 2, it will be the same. So let us solve now. So mole is already there here, mole already there. So 1 already there, minus, it will go 3 by 2, so it will take the negative sign, minus 3 by 2. Liter, what is there? Minus 1 is there, it will go the plus. So that is minus 1 plus 3 by 2. And what is there, student? Second inverse already there. Solve it. So what will be there, student? Here is mole. So minus 1 by 2 will come, minus 1 by 2. Liter, what will be there? 2 minus 3 plus. So that is plus 1 by 2. That is, and second inverse. So this is the dimension of the K, student. So little bit you will find that is mathematical calculation, but overall is correct one. Now let us try to understand the last one, fourth one. What can be the our answer here, student? Okay. See, you if you follow the rule, student, okay, system, if you follow step by step, nothing is the problematic one. You know, all the answers you can be able to get here. So let me, till now I am not used to this huge, because at once how can erase this one, I don't know, that why it is taking time. Fourth one. So R is equal to rate, they have given K C2H5Cl. So here power is nothing there, so power means 1. So order become what, student? Order become what is 1 order. So unit, if you are writing, student, what can be the unit? So K, here you are writing the concentration power 1. So unit, unit means that is what, student? Here R is there na in this term. So I am simply writing here R. Okay. So here if you are writing the R means what, student? Mole per liter per second. This is the rate. And K, and concentration unit, what is there, student? Mole per liter. This mole per liter say cancel out. So K is equal to what is? Second inverse. So first order unit is what, student? Second inverse. So this is the answer. Now go with the second question. Okay, it's taking time little bit, student. Here the question is very nice question we got, student. Question number 2. For the reaction they have given, student, what is 2A plus B? It is going to give A to B. The rate. So R is equal to what? R is equal to, see, R is equal to how much they have given, student? K A, okay, B. It is experimental, student, so nothing to relate with the coefficient. So K A and K power 1, K A power 1, B power B square. K is equal to, they have given here. So K, if I will write, student, what is 2.0 into 10 power minus 6. This is mole square liter is mole per square liter square second inverse. Calculate the initial rate of the reaction, where A is given. How much A is given, student? 0.1. B is given 0.2. Okay. So here we have to calculate initial rate of reaction, right? So they are asking R. What will be the R? Okay, R1. Then they are saying the rate of reaction A reduced to 0.06. This time we have to calculate. So 2 times we need to calculate rate. So K value, what is, student? 2.0 into 10 power minus 6. A value 0.1 and B value what is 0.2, that is going to be square. Now what we can do here, student, let me take out the mobile for the calculations. Here you see, student, so 2.0 into 10 power minus 6 multiply by 0.1 multiply by 0.2 multiply by 0.2, because here square is there, so 2 times we wrote it, student. So what is going to be our answers, right? So here, so power, you see student, power, so first of all we are solving power. So here is decimal is 1 digit, 2 digit, 3 digit. So 10 power, it is 10 power, what is minus 9. What is the here? 2 2 ja 4, 2 ja 8. So 8.0 into 10 power minus 9. So this is, what is the unit? Unit will be mole per liter, okay, mole per liter, okay, per second. This is the rate. Now let's try to go for the second part, student. Second part, okay. If you see, student, the solution of this question, whether it's correct or not, because the calculation can be sometime wrong also. This, let me check out the solution. It's correct, student. Now the second part we are going, student. So if you see the second part, they are saying the rate we have to calculate when A is reduced to 0.06. So A is how much final concentration? 0.06. This we have to take. Now B, what will be the B? B. So how to get the concentration of B, student? This is the final concentration of the A, student. Final concentration of A. Final. So how much utilized concentration of A? Utilized concentration of A. So utilized concentration means what, student? Initial minus final. So initial concentration how much? 0.1 minus 0. How much? 6. So 0.06, student. 0.06. Okay, here 0.06. So how much coming, student? 0.04 will come, student. You can check out if you are trying here. 0.1 minus 0.06, so 0.04. According to question, student, according to questions, according to equation. So according to equation, if you are talking, so 2A plus B, it is going to give A to B. So whatever the A is reacting, it is the half is B is reacting, because here 2 is there. So if it is the 0.04 reacted, so how much it is reacting, student? 0.02, right? 0.02. So this is used, this concentration is used. So final concentration, how to calculate final? So final calculation concentration, so initial minus used one, initial minus used one. So initial concentration of B is 0.2, this is 0.2 minus 0.02. So how much is coming, student? You see 0.2 minus 0.02. So it is coming, student, dear student, 0.18. Now you got the final concentration of both, student. Now, so rate is equal to, what is the rate, student? Rate expression they have given. What is the concentration of A and B? Here is K is as it is, and B power, what is there? 2. This is the given, student. Please don't get confused, student. Rate is equal to, what is this? Is Ka and B square. So here you go, Ka B square. So K is equal to, this is 2 into 10 power minus 6. A concentration, final concentration, how much, student? Just now we see na 0.06. Here is 0.06. What is the B concentration? 0.18. That is going to be square. Now solve it. So 2 into 10 power minus 6 into 0.06 into 0.18 multiply by 0.18. Solve it. Solve it, student. So if you are solving, student, so you can firstly you solve the power, student. So 2 into 6 into 18 into 18 multiply by 10 power. So minus 6 is there, here is 2, minus 8, here is 2, minus 10, and here is minus 12. So this is coming minus 12. Now solve it. If you are solving, here very 2 multiply by 6 multiply by 18 multiply by 18. So it is how much coming, student? 3,888 into 10 power minus 12. So you solve, put the decimal here, 3.89 into 10 power 3 digit decimal. So this will become minus 9. Unit is what? Mole per liter per second. This is, so this is what the correct answer will be, like that, student. I hope this will be helpful to you to understand, student. Okay, so the answer is absolutely correct. Now go with the question number 3 here. Yeah, it's very nice question, student. They are saying the decomposition of NH3 on platinum surface is zero order reaction. What are the rate of production of N2 NH2 if K value they have given, right? So it is zero order reaction now. This is, so let us firstly, decomposition is there, student. You write NH3, it is going to give, student, N2 plus 3H2. So you can balance it 2. So rate if you are writing, student, so what will be? Minus 1 by 2, and here is NH3. Okay, here is dNH3 upon what is dt is equal to plus dN2 by what? dt plus 1 by 3, coefficient we divide is not plus, positive, 1 by 2, and 1 by not 2, student, actually it is 1 by 3 because coefficient is 3. So here this 2 will be on the bottom. So here is 2. So here is what is 3 dH2 upon what is there, student, dt. These things are there. Friend, they are saying it is the zero order reactions. So in the zero order reaction, what is there? We are write K, A, and whatever the concentration is there, power 0. So rate is equal to anything power 0 is 1. So rate it will be equal to what? K, right? So they are saying production of N2 we will see in the term of the production of N2. So R is equal to what is there, student? dN2 by dt is equal to, it will be the K, because here power no, it will be equal to K. So how much it is going to be, student? 2.5 into 10 power minus 4, and it will be the same, mole inverse liter second inverse. So first case it will be same, student. The second case, you see, second case, case 2. So what is case 2, student? Here is the R, okay, is equal to, you can write, student, what are there, student? 1 by 3 in the case of H2. So here is 1 by 3 dH2 by dt, dH2 by dt is equal to, it is going to be K. So dH2 by dt, right, student? So what is the 3 into K? 3 into K. So 3 multiply by K. K value what, student? 2.5 into 10 power minus 4. You can multiply. So it will be 7.5 into 10 power minus 4. Unit if you are writing, student, those unit will be same, mole inverse liter second inverse. So this is what the answer is, student. So decomposition of platinum surface is zero order reaction. What are the rate? So in case of the zero order reaction, here is power becomes the 0. So that is rate is equal to the K. So that way you can calculate. Now go with the question number 4, student. What is the question number 4? Here. Student, this question is appear to be very long, but it's not very long. They are saying the decomposition of dimethyl ether leads to formation of CH4NH2 and CO, and the reaction rate is given by rate is equal to CH3OCH3. Here they have given. So two part this question I am writing. Rate is equal to what, student? K, CH3OCH3, and power is how much, student? 3 by 2. The rate of reaction followed by increase in pressure in the closed vessel. So the rate can also be expressed in terms of partial pressure of dye. So here they are also writing, that is what, student? K, and partial pressure of the CH3OCH3, and it is going to be 3 by 2. if the pressure is measured in bar and time minutes, then what is the unit of the rate of constant? So here students, this is the 3 by 2. So rate is equal to, this side you will write that is bar minute inverse, bar minute inverse. So k, what will be this side, student? So 3 by 2 is there, so it will be again bar power 3 by 2 and minute power 3 by 2. So k, you go and calculate the k. So k you rearrange this one. So bar minute inverse is there, minute inverse divided by bar 3 by 2 and minute 3 by 2. Friend, let us solve it. So bar here is there, power nothing means 1. So 1 minus 3 by 2 student, and minute is there, minus 1 is there, minus 3 by 2. These things are there. Solve it, friend, solve it. So it will be there bar, so 2 minus 3 by 2, so minus 1 by 2, and minute what will be there, student? Minute. This minute is minus, student, this will be minus. Here is the minus is there, okay, bar per minute is there, na? So it will go in the numerator, so it will become positive. So what is there, student? 2 1 ja 2 plus 3, so 1 by 2, student. So bar minus 1 by 2, minute 1 by 2. Here if you are writing in this term, so it is what is, student? Mole per liter per second. This is the rate. Here is k. What is there, student? This one is, so mole power 3 by 2. Here is plus 3 by 2 and liter power 3 by 2. So k is equal to what? So k will be what? Mole minus that is, here is 1 already there because it is the numerator, and here it will go this side, so it will take minus sign. So minus 3 by 2, and here liter minus 1 is there, and it will go, this is the minus mole per liter, so it will go 3 by 2, and minute inverse is there, not the second, this is the minute. So minute inverse, solve it. So that is mole is there, student. So that is 2 1 ja 2, so minus 1 by 2, liter 1 by 2, and minute inverse. So this is the what the k unit in the terms of concentration, mole per liter in the term of bar. So this is the answer. Now next problem is to you, student. What is the next one? Mention the factors that affect the rate of a chemical reaction. What are the factor? Rate depend, student, rate. So first one is their temperature. So temperature, student, if you reach the 10 degrees C, student, the rate will become double. Rate becomes what, student? Double. Rate becomes double. So first thing is there, that is the chemical reaction are greatly affected by the rate, student. Greatly affected by temperature. Greater the temperature, greater will be the rate of reaction. This is the first thing. Now go with the second one. This is the one. Now go, second one is catalyst, student. Catalyst. So catalyst, what they do, student, catalyst decreases the activation energy and increases the rate of reaction. So catalyst also increases the rate of reaction, student, for a spontaneous reaction. Non-spontaneous reaction is not affected by the catalyst. Okay. So this is what the catalyst. Now if you are talking about the pressure, third, if the reaction is taking reaction are in the gaseous state, so increase the pressure, student. Increase the pressure if you are increasing, student. So rate will also increase, student. This is what. Next one is there, student. Fourth one, you can use the concentration. So student, if your concentration increases, so what will happen? Rate will also increase. So these are the terms, student, where the rate is depending the temperature, catalyst, pressure, concentration, type of reactant, many more factors are there that are there. Okay, so now the remaining problem we will do in the next video, student. I don't want to make the video very long. So this is the what about the today's class. Thank you so much for watching, students.